Which of the following expressions is equivalent to the quantity A plus B times the quantity A minus B? Well, this is actually a rule that you would memorize, but you don't have to memorize it. You can always just take these binomials and multiply them together using FOIL. The F stands for first, meaning to multiply the first terms in each set of parentheses. So A times A. And A times A is A squared. Then O stands for outer or outside. So you multiply the two terms on the outsides, or A and negative B. So A times negative B is negative AB. I stands for inner or inside. So you multiply the two terms on the inside, B and A. B times A is BA or AB, so plus AB. And finally, the L stands for last. So you multiply the two terms that are in the last positions of each set of parentheses. Positive B times negative B, which is negative B squared. Then to simplify, we combine like terms. Negative AB and positive AB are like terms, and they cancel each other out because they're additive inverses of each other, or opposites. So we're left with A squared minus B squared, or answer A. A combination lock uses a 3-digit code. Each digit can be any of the 10 available integers 0 through 9. How many different combinations are possible? In this probability problem, there are 3 independent events. Independent meaning they don't affect each other. So to find the possible outcomes, we would have to find the product of the possible outcomes for these 3 independent events. So the possible outcomes would be first the possible outcomes for the first digit, 10, since there are 10 available numbers, times the possible outcomes for the second digit, which again is 10 integers, times the possible outcomes for the third digit, which is again 10. So the probability is 10, or the possible outcomes is 10 times 10, which is 100, times 10, which is 1,000 possible outcomes. This is the quicker way to do it. Of course, you can always see by actually writing the combinations. 0, 0, 0 would be the first. Then 0, 0, 1, 0, 0, 2, 0, 0, 3, 0, 0, 4, 5, 6, etc., all the way up to 999, which makes it seem like there are 999 possible outcomes. But really, we have to count this first one, the 0, 0, 0, which gives us the total of 1,000 possible outcomes. A tire on a car rotates 500 RPM, or revolutions per minute, when the car is traveling at 50 kilometers per hour. What is the circumference of the tire in meters? Well, the first thing I want to do is take this 50 kilometers per hour and convert it into meters, since that's what they want the circumference in. So to convert kilometers to meters, I multiply it by the conversion factor of 1,000 meters is 1 kilometer. And when I multiply these fractions, I can cross-cancel these units, kilometers, and I'll be left with meters per hour. And I'll go ahead and do that first. So our kilometers cross-cancel. 50 times 1,000 is 50,000 meters per 1 hour. So every hour, this car goes 50,000 meters. And we know that it goes 500 revolutions every minute. So then I want to convert my 50,000 meters per hour into meters per minute so I can more easily compare it to my revolutions per minute. So I'll multiply it by the conversion factor of 1 hour is 60 minutes. So again, my hours cross cancel since I'm multiplying fractions, and I get 50,000 meters every 60 minutes. What I want to find, though, is what 1 revolution is. How many meters is 1 revolution? Because 1 revolution is 1 time all the way around the tire. And that would be the circumference, which is what they're asking me for. So I'm going to take this 50,000 meters per 60 minutes and multiply it times my 500 revolutions per minute. So every 1 minute, the car goes 500 revolutions. So that again, my minutes, these units, minutes cross cancel. And I can cross cancel my 50,000 and my 500 by dividing them both by 500. And 500 divided by 500 is 1. And 50,000 divided by 500 is 100. So then 100 meters times 1 is 100 meters divided by 60 revolutions. So now I found that every 100 meters, this car, it's going 60 revolutions every 100 meters, which I can then simplify by canceling out the zeros, and I get 10/6 meters per revolution. So it goes 10/6 of a meter every revolution. And again, a revolution is 1 time all the way around the wheel, which is the circumference. So our circumference is 10/6. Chan receives a bonus from his job. He pays 30% in taxes, gives 30% to charity, and uses another 25% to pay off an old debt. He has $600 remaining from his bonus. What was the total amount of Chan's bonus? First, I want to start with totaling the percentage that he spent or used, the percentage that is not left. So he pays 30% in taxes, gives 30% to charity, and uses the 25% to pay off an old debt. So that's a total of 85% that he has used, which means he had 15% left. And the $600 is the 15% of his total. $600 is 15% of the total amount of his bonus. 600 is equals, change the percent to a decimal, of means to multiply, and we don't know the total, so use a variable, like t. And now we just need to solve for t. So divide both sides by 1500ths. So 600 divided by 1500ths. We need to move the decimal 2 places to the right, so we do the same to 600, add 2 zeros, and 15 goes into 60 4 times. 15 times 4 is 60. You subtract and get 0. When you bring down 0, 15 goes into 0 0 times, and that's just going to keep happening 2 more times until we get 4,000. So what was the total amount of Chan's bonus? $4,000. Dorothy is half her sister's age. She will be 3/4 of her sister's age in 20 years. How many years old is she? We have 2 unknowns here. We don't know Dorothy's age, and we don't know her sister's age. So I'm going to make up 2 variables for those. I'm going to use D for Dorothy's current age. And I'll use S for the sister's current age. And I say current because they're talking about their ages now and then also their ages in 20 years. But what we want to know is how many years old she is now. So we're going to deal with their current ages. So first we have that Dorothy is, and is in math means equals. It's one of my favorite words. I love the equal sign. So Dorothy equals half her sister's age, so half S. So it's kind of like translating. You're translating from words into mathematical equations. The next sentence says she will be, so Dorothy, will be 3/4 of her sister's age in 20 years. So Dorothy in 20 years will be 3/4 of her sister's age in 20 years. Remember that D and S were Dorothy and her sister's current ages. So when they talk about in 20 years, that means we have to add 20 to their current age. So Dorothy's age in 20 years, so plus 20, will be, or equals, 3/4 of her sister's age, also in 20 years. So we want to solve for Dorothy's age, obviously, and we can do this in lots of different ways. But the first thing I notice is that since I know that D is 1/2 S, I can replace D in this equation with 1/2 S, and that's called substitution. So that's the method I'm going to use. I'm going to replace D with 1/2 S plus 20 equals 3/4 times the quantity S plus 20. Well, from here we have lots of options for solving. And the first thing I think about is, really I just want to get rid of this fraction, this 3/4. So I think I'll start by distributing the 3/4 to what's inside my parentheses. So I have 1/2 S plus 20 is equal to 3/4 S plus, and then with the 3/4 and the 20, I can put 20 over 1, and I can simplify multiplying these numbers by cross-canceling 4 and 20. I'm simply multiplying two fractions together so I can use this shortcut. I'm going to divide both 4 and 20 by 4. 4 divided by 4 is 1, and 20 divided by 4 is 5. So 3 times 5 is 15. 3/4 of 20 is 15. That makes sense. Okay, so we need to get all of our variables on the same side. So to do that, I'm going to subtract 1/2 s from both sides. 1/2 s minus 1/2 s is 0. I'm going to bring down 20, and that equals. Now, to subtract fractions, I have to have common denominators. So 1/2 is also 2/4. So I'm going to change 1/2 to 2/4 so that I can subtract these. And then when I subtract, you just subtract the numerators. 3 minus 2 is 1, and your denominators stay the same, 1/4 s, plus 15. Next, I need to subtract 15 from both sides. 20 minus 15 is 5, and 5 is 1/4 of the sister's age. So finally, I need to multiply both sides by the multiplicative inverse of 1/4, which is 4/1, or just 4. So multiply both sides by 4. 4 times 5 is 20, and 20 is her sister's age. 1/4 of 4 is 1. So we're left with S, the sister's age. Well, remember that Dorothy is half of her sister's age. So since we now know her sister's age is 20, we know that Dorothy is half of that, and half of 20 is 10. So that means Dorothy is 10 years old. You could have solved this also by just kind of playing with the numbers, playing with the answers, and seeing which ones would work with the information you were given. But I always love to solve a good algebra problem. The Charleston Recycling Company collects 50,000 tons of recyclable material every month. The chart shows the kinds of materials that are collected by the company's 5 trucks. Approximately how much paper is recycled every month? This pie chart is a total of 100%. And it's a total 100% of 50,000 tons. So this 40% means 40% of the total. Paper is 40%, so 40% of the total amount of recyclable material collected, or 50,000 tons, 40% of that is paper. And that's what we want to find, is how much is that? Well, of means to multiply. And I'm going to multiply 40% and 50,000, which means I need to change 40% to a decimal. So move the decimal 2 places to the left. So I'm actually multiplying 4/10, or 40/100ths, it's the same thing, times 50,000. So we have 50,000 times 4/10. 4 times 0 is 0, 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 and 4 times 5 is 20. We have one number behind the decimal, so our answer should have one number behind the decimal, and we get 20,000 tons. So 20,000 tons of the total 50,000 tons of recyclable material is paper. The Charleston Recycling Company collects 50,000 tons of recyclable material every month. The chart shows the kinds of materials that are collected by the company's 5 trucks. What is the second most common material that is recycled? This is a pie chart, and a pie chart is a visual representation of data. The data represented in the chart will add up to a total of 100%. 40% plus 25% plus 15% plus 5% plus 15% is a total of 100%. The larger the slice, the larger the percent. And the larger the slice and percent means the more common that piece of data is, or the more times that data occurs. So in this case, they're asking what the second most common material is. And we can see that paper is the most commonly recycled material. It has the largest slice of the pie, and thus the largest percentage. So the second most common recycled would be glass at 25%. B. Arrange the following numbers in order from least to greatest. 2 cubed, 4 squared, 6 to the 0 power, 9, and 10 to the first. The first thing we need to do is simplify these numbers. 2 cubed means 2 times itself 3 times. So that's 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So that is 8. 4 squared is 4 times itself 2 times. 4 times 4 is 16. Now this next one is very interesting because it doesn't matter what this number is. The base number doesn't matter. Any number raised to the 0 power is always 1. 9, of course, is simply 9. And 10 to the first is 10 times itself, 1 time. Or not really 10 times itself at all, it's just 10. You're not multiplying 10 by anything else, because you just have 10 written 1 time. And now they want these numbers in order from least to greatest. So the smallest number would be 1, followed by 8, then 9, 10, and 16. But of course, those are not in our answer choices because the numbers are written as they originally were. So now I'm going to go back and write them the way they were written to begin with. 1 was 6 to the 0. 8 was 2 cubed. 9 was always 9. 10 was from 10 to the first. And 16 was 4 squared. And now we just need to find which answer choice has this as the answer. So of course we should be starting with 6 to the 0, so that takes it down to either B or D. But then the next should be 2 cubed, which is not the case for B, so our answer is D. Raphael has a business selling computers. He buys computers from the manufacturer for $450 each and sells them for $800. Each month he must also pay fixed costs of $3,000 for rent and utilities at his store. If he sells N computers in a month, which of the following equations can be used to calculate his profit? Profit. Profit is found by subtracting the money you spend from the money you earn. So we know that he earns $800 for each computer that he sells. That's money he earns, $800 for each computer, which means to multiply times the number of computers he sells. And that's all the money he makes, so everything else is money he spends. So from the money he earns, we need to subtract $450 for each computer, because that's how much he has to pay the manufacturer. So minus 450 in. And we also have to subtract $3,000 flat. So just $3,000. Now if we compare what we have to these equations, we know we can already eliminate A. It doesn't even take the $3,000 into account, so A's out. On B, if we distributed this in, we'd be subtracting $3,000 in, which is not right. We're not losing $3,000 for every computer we sell, so B's out. On C, it has us multiplying $3,000 times in, which would be great. He'd be making tons of money, but that's not this situation. In D, when we distribute the number of computers, n times 800, 800 n, minus n times 450, so minus 450 n, and then minus 3,000. So D's looking pretty good. The problem with E is, instead of subtracting the $3,000 he spends on rent and utilities, they're adding it back in like that's more money he's making. But he's not making that money, he's losing that money. So D would be the correct answer choice. In a game of chance, 3 dice are cast simultaneously. What is the probability that all 3 will land with a 6 showing? Well, the probability of just 1 dice landing with a 6 showing is 1 out of 6. Since one of the numbers is a 6 out of a total of 6 numbers. And the other 2 dice have the same probability. So times 1/6 times 1/6. All of these events are independent of each other, meaning they don't affect each other, which is why we just multiply the 3 probabilities of the 3 dice together. So that means that the probability is 1 out of 6 times 6 is 36, times 6 is 216. So 1 in 216. Which, if you really think about it, makes a lot of sense. It's not very likely that when you roll 3 dice, you're going to get 3 6s. It's very unlikely. It doesn't happen very often. Maybe 1 time out of 216 times that you cast those dice. The expressions y equals negative 3x plus 6 and y equals 2x minus 4 represent straight lines. Compute the coordinates of the point at which they intersect. This can be done by substituting 2x minus 4 for y in our other expression, or by substituting negative 3x plus 6 for y in this expression. Either way, the result is 2x minus 4 equals negative 3x plus 6. Now we need to solve for x. First, I'll add 3x to both sides so that I can get all my x variables on one side of the equation. 2x plus 3x is 5x minus 4 equals negative 3x plus 3x cancels, and I'm left with 6 on the right side. Now we need to add 4 to both sides. Bring down the 5x. Negative 4 plus 4 is 0 equals 10. And finally, we need to divide both sides by 5 to solve for x. 5 divided by 5 is 1, times x is x, and that equals 10 divided by 5, which is 2. We're halfway there now. We've found what x is. To find y, we need to substitute 2 for x in either one of these expressions. And I'm going to use the second one. Since x is 2, we need to replace x with 2 to find y. So y equals 2 times 2 minus 4. Y equals 2 times 2 is 4 minus 4. So y equals 0. Our ordered pair is 2, 0. And you can always check this by plugging this ordered pair back into both of your expressions, and you should get a true mathematical equation there when you do that. And if you didn't, then you know that you made an error somewhere in your work. In the figure, segment BC is 4 units long, segment CD is 8 units long, and segment DE is 6 units long. What is the length of segment AC? The first thing I'd like to do is take this information and actually put it on my picture. So segment BC is 4 units long. Here's segment BC, it's 4. Segment CD is 8 units long. CD is 8. And segment DE is 6 units long. DE is 6 units long. These triangles are not congruent, and that's obvious. If you're looking at them, you can see this triangle smaller than the other one. However, these right angles are congruent. These vertical angles are congruent. And since 2 angles of this triangle are congruent to 2 angles of the other triangle, that means that the third angles, angle E and angle A, are congruent to each other. Therefore, these 2 triangles are similar to each other because all 3 of their corresponding angles are congruent to each other. And since these triangles are similar, that means that their corresponding sides are proportional. You see that segment BC is half of segment CD. 4 is half of 8. So if we can find the length of segment CE, then we know the length of segment AC is half of that. We're going to find the length of segment CE using the Pythagorean theorem. A squared plus B squared equals C squared. We have our 2 legs. 8 squared plus 6 squared equals C squared. 8 squared is 64, plus 6 squared is 36, equals C squared. 64 plus 36 is 100, equals C squared. Then to solve for C, we need to square root both sides. The square root of 100 is 10, and the square root of C squared is C. So the length of segment CE is 10. And again, the lengths of the sides of triangle ABC are half the corresponding sides of triangle CDE. So since the length of segment CE is 10, that means that the length of segment AC is half of that, or 5. So answer B. Carrie wants to decorate her party with bundles of balloons containing 3 balloons each. Balloons are available in 4 different colors. There must be 3 different colors in each bundle. How many different kinds of bundles can she make? With this kind of a problem, since our numbers are so small, you could just make up some colors. How about red, blue, green, and yellow? Because the balloons come in 4 different colors. And she wants to make bundles with 3 balloons each. And they must be 3 different colors. So we could make a bundle that is red, blue, and green all together. We could also do a bundle that is red, blue, and yellow. And then we could do a bundle that is red, green, and yellow. And those are all the bundles of balloons that we can do with red in them. So now let's move on to blue. We could put blue, green, and yellow together. And that's it. There are no other combinations of 3 balloons with these 4 colors where there are 3 different colors. So that means there's a total of 4 different kinds of bundles that she can make. We can do this mathematically using the formula for a combination. A combination is found by doing n factorial divided by n minus k factorial times k factorial, where n is the number of items and k is basically how many you choose at a time or taken at a time. So in our case, we have 4 items. We have 4 different colors of balloons. So our n is 4, but we can only choose 3 at a time because we want 3 in each bunch. So our k is 3. So our combination would be 4 factorial divided by 4 minus 3 factorial times 3 factorial. And all I did was substitute 4 for n and 3 for k. Simplifying that, 4 factorial just means to do 4 times 3 times 2 times 1. Divided by 4 minus 3 is 1, 1 factorial is just 1. Times 3 factorial, which is 3 times 2 times 1. 3 divided by 3 is 1, 2 divided by 2 is 1, 1 divided by 1 is 1. So we're left with that C equals 4. There are 4 different combinations you can make. So either way you do it, we get 4. There are 64 squares on a checkerboard. Bobby puts 1 penny on the first square, 2 on the second square, 4 on the third, 8 on the fourth, and continues to double the number of coins at each square until he has covered all 64 squares. How many coins must he place upon the last square? The first thing I want to do is take this information out and organize it. So I've got 2 pieces of information here. I've got these number of squares and also how many coins are on the squares. So I'm going to organize it as squares and number of coins. So it says he puts 1 penny on the first square. So square 1, 1 penny. 2 on the second square. Second square, 2 pennies. 4 pennies on the third square. So third square, 4 pennies. 8 on the fourth square. So fourth square, 8 pennies. And so on like that. It keeps doubling. So another important word here is double. Really, we don't even have to find the pattern. They told us what it was. We're doubling. So this is 1 times 2 is 2. Times 2 is 4. Times 2 is 8. So since I know I'm doubling, then I have a base of 2. So on the first square, I have 2 to the power of 0. Any number to 0 is 1. So on my first square, I have 2 to the power of 0 coins. On my second square, I have 2 to the first power coins. 2 to the first power is 2. On my third square, I have 2 squared coins. 2 squared is 4. On the fourth square, I have 2 cubed coins. 2 times 2 times 2 is 8. So as you can see, as we increase our number of squares, our exponent also increases. The first square had 2 to the power of 0 coins. So the exponent is 1 less than the square that we're on. Second square, 2 to the first power. The exponent is 1 less than the square we're on. Third square, 2 to the second power. The exponent is 1 less than the square we're on, and so forth. So then how many pennies will be on the 64th square? Well, we know that we're going to have a base of 2, and our exponent is going to be 1 less than the square we're on. So we'd have 2 to the 63rd power number of coins on our 64th square. Just answer C. Which of the following statements is true? A. Perpendicular lines have opposite slopes. Close but not quite. It's missing an important word here, and that word is reciprocal. Perpendicular lines have opposite reciprocal slopes, so that is not true. B. Perpendicular lines have the same slopes. Again, not true. That would be parallel lines that have the same slope. Parallel lines are lines that never touch, never intersect. So their slopes would need to be the same so that they would never touch each other. For instance, let's say these lines had a slope of 1/2. Then this line we go up 1 over 2, up 1 over 2, same thing here, up 1 over 2, up 1 over 2, and that way our lines never touch. So it's parallel lines that have the same slopes. So this statement is also not true. C. Perpendicular lines have reciprocal slopes. Again, close but missing a very important word, and that is opposite. They have opposite reciprocal slopes. So this is also not true. D. Perpendicular lines have, finally, opposite reciprocal slopes. This statement is true. Perpendicular lines do have opposite reciprocal slopes. And E is also not true. It says they're unrelated. Oh, that is so not true. They definitely are related. For instance, let's just take the graph of y equals 2x and y equals -1/2 x. These are two lines that have opposite reciprocal slopes. Opposite meaning that they have different signs. One's negative, one's positive. And reciprocal meaning that the fraction is flipped. So this slope is 2 over 1, whereas this one is negative 1 over 2. Notice how the fraction is flipped. So first I'll graph y equals 2x. Let me put some marks on my graph here. So y equals 2x, we would go up 2 over 1. And y equals negative 1/2 x, down, okay, sorry, we could actually graph a line here. It's going through the origin because there is no y-intercept. So there is that line, the y equals 2x line. And then y equals negative 1/2 x, again, would also go through the origin since it has no y-intercept. And from there, we would go down 1 and over 2. So you can see how these lines intersect each other at right angles because they have opposite reciprocal slopes. Determine the midpoint of the line shown in the figure. We will use the midpoint formula to find the midpoint of this line. The midpoint formula is x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. So what you're doing is you're adding your two x coordinates together from the two endpoints and dividing that sum by 2, basically finding the average of the x values, which would be the middle of the x values, and then doing the same with your y coordinates of your two endpoints. You'll add those together and then divide that sum by 2. Again, finding the average of those y coordinates or the middle of the y coordinates. So when you find the middle x coordinate and the middle y coordinate, you'll then have the coordinates of the midpoint. But first we need to know the coordinates of our endpoints. So this endpoint is at negative 1, 2, 3, 4, positive 1, 2, 3, 4. So these coordinates are negative 4, 4 for this endpoint. And this endpoint is at 1, 2, 3, 4, 5, 6, negative 2. These are my x1, y1, x2, y2 coordinates. And it doesn't matter which one you label as your x1, y1, as long as you label them consistently. For instance, this could not be my x2, y1. Since this is my x2 coordinate, that means this is my y2 coordinate. And those subscripts, the 1s and the 2s, all that means is this is the first point, this is the second point. But it really doesn't matter which point is your first and which point is your second. So I just usually label them from left to right. And now all we need to do is substitute and solve. So the midpoint is x1 plus x2, so negative 4 plus 6 divided by 2. And then y1 plus y2, 4 plus negative 2, divided by 2. Now we need to simplify by adding. Negative 4 plus 6 is 2 divided by 2. 4 plus negative 2 is 2 divided by 2. And finally we divide. 2 divided by 2 is 1. 2 divided by 2 is 1. So the midpoint is 1, 1, which you can see on this graph, over 1, up 1. And you know that point does look like it's right in the middle of that line. So that's our midpoint. The table shows the cost of renting a bicycle for 1, 2, or 3 hours. Which of the following equations best represents the data if C represents the cost and H represents the time of rental? Since this is a multiple choice question, you could always substitute these values or substitute these values for hours into your equation and see if you get the cost. For instance, you could replace H with 1, and you have $3.60 or $3.60 times 1, which is $3.60, which is the cost for 1 hour. And then do the same with 2 and with 3. Because sometimes an equation will work for one set of data, but not for the other two. So you should test it on all of them. However, I'll show you how to solve this problem if it weren't multiple choice. So we're going to write our own function rule using the data. First, looking at hours and cost, your cost is dependent on the number of hours you rent the bike. Cost then is the dependent variable. And I want to focus on my dependent variable and see what kind of changes are happening. So from $3.60 to $7.20, I'm adding $3.60. From $7.20 to $10.80, I'm again adding $3.60. So I can see that the change in Y is constant, or the change in the cost in the dependent variable is constant. I want to now compare and see what's happening with my independent variable, my time. So from 1 to 2, I increase by 1. From 2 to 3, I also increase by 1. So there's a constant change in my independent, my time, as well. This tells me that there's a linear relationship here. So to write my function rule, I simply need to find my rate of change, which is the change in Y divided by the change in X. And the Y, that's the dependent variable, whereas X is the independent variable. And we've already established that our cost is dependent, therefore our cost is our Y. And we've already found the change in Y, it's $3.60. Divided by the change in X, 1. So our rate of change is simply $3.60. And that rate of change is what you're multiplying the independent variable by to get the dependent variable. So I've now found that the cost is equal to $3.60 times my independent variable of H. And then we can check and see if it works. So let's replace H with 1. $3.60 times 1 is $3.60. Try it with 2. $3.60 times 2 is $7.20. Finally, 3. $3.60 times 3 is $10.80. So that verifies that our function rule works for this situation and is correct. So answer A. Triangle ABC is a right triangle, and angle ACB is 30 degrees. What is the measure of angle BAC? Well, the first thing I want to do is fill in this information. that angle ACB is 30. ACB is this angle right here, and it's 30 degrees. So I know 2 out of the 3 angles of my triangle. And I know that the 3 angles of a triangle add to be 180. So that means that this 90-degree angle plus this 30-degree angle plus the measure of angle BAC right here equals 180. The first thing I need to do is combine like terms. 90 plus 30 is 120, plus the measure of angle BAC is 180 degrees. To solve for the measure of angle BAC, we need to subtract 120 from both sides. 120 minus 120 is 0. Bring down the measure of angle BAC equals 180 minus 120 is 60. So that means the measure of angle BAC is 60 degrees. Which of the following could be a graph of the function y equals 1 divided by x? Let's start with B. This is a linear function. In fact, it even looks like the parent function of a linear function, which is y equals x. So not y equals 1 divided by x. By the way, this is called a rational function. The root ratio means a comparison of 2 numbers, or a fraction. And B is not the graph of a rational function. It's the graph of a linear function. C is a quadratic function graph. This parabola is graphed from a quadratic function. And this also looks like the parent form. The parent form of a quadratic function is y equals x squared. So this would also not be the graph of a rational function. On D, this is what an exponential function looks like. It starts out increasing slowly, but then it begins increasing faster. And that parent function is y equals a number to the x value, or b to the x. That's not the parent function, that's just the form. And it's actually y equals a times b to the x. But again, not a rational function. And then, so we can eliminate D. And then on E, this is very similar to B. It's another linear function. It graphs a line. And it's not the parent function this time, but it's still a linear function. So it's in this form, y equals mx plus b. So still, with a linear function, our x is not in the denominator like our rational function. So that one's out as well. Which means we're left with A, which is the graph of a rational function. Something you can think about with rational functions is that the only number you can't divide by is 0. Notice how on this graph, your domain is never 0. On this side of our graph, it's approaching 0 and then it turns down sharply away from 0 because your x value can never be 0 since you cannot divide by 0. It's the same thing in the first quadrant. Again, it's approaching 0 and then it turns sharply away from 0 because x can never be 0. Your y value will also never be 0 So again, you can tell in this graph our y value never reaches 0. However, in all of these other graphs, we do have an x value of 0. There it is, right there. Right there, our x value of 0. And so that's another way to tell that A is the solution. A is the graph of the function y equals 1 divided by x. If 12 divided by x is equal to 30 divided by 6, what is the value of x? This is a proportion. A proportion is a ratio set equal to a ratio. And a ratio is simply the comparison of two numbers, or a fraction. And proportions are pretty cool because their cross products are equal to each other. That means that 12 times 6 is equal to x times 30, which we could simplify to say 72 is equal to 30x. And then we can solve for x by dividing both sides by 30. So 72 divided by 30. 30 goes into 72 2 times, which gives us 60. We subtract and we get 12. So we add a decimal and a 0 and bring down the 0. And 30 goes into 120 4 times. 30 times 4 is 120. We subtract and get 0. So that means that 2 4/10 is equal to x, which is answer B. Which of the following expressions is equivalent to x cubed times x to the 5th? First of all, we need to recognize that when you have two letters or a number and a letter next to each other with no operation symbols in between them, meaning there's no addition sign, subtraction, division, it is always understood that without any of those other operation signs, that we are multiplying these together. So this is x cubed times x to the 5th. And an exponent simply tells you how many times to multiply the base times itself. So x cubed means we're multiplying x times itself 3 times. And then we're multiplying that times x to the 5th, which is x times itself 5 times. So really, we're multiplying x times itself a total of 1, 2, 3, 4, 5, 6, 7, 8 times. So x cubed times x to the 5th is the same as x to the 8th. Now there is a rule for this so that you don't have to go through this step every time. And the rule is when you multiply with the same bases, the base being, like in this case, x, then you simply add the exponents together. So 3 plus 5 is 8, so it's x to the 8th, which is answer choice D. If x plus y is greater than 0, when x is greater than y, which of the following cannot be true? This word when is very important because it means we're only looking at the situations when x is greater than y. So first we should go through our answers and eliminate the ones that don't satisfy this inequality. Is 3 greater than 0? Yes, so it stays. 6 is greater than -1, so it stays. -3 is not greater than 0, which means C must be eliminated as a choice. -4 is not greater than -3, so it must also be eliminated as a choice. 3 is greater than -3. So the 3 answers left are the only ones that satisfy this inequality. So now we need to check to see if they satisfy the first. So we'll take A, 3 plus 0 is greater than 0. 3 plus 0 is 3, and that is greater than 0, so it works. B, 6 plus -1 is greater than 0. 6 plus -1 is 5, and 5 is greater than 0. And finally, E, 3 plus -3 is greater than 0. 3 plus -3 is 0, but 0 is not greater than 0. 0 is simply equal to 0, so this one is not true. So we found our answer, E. A motorcycle manufacturer offers 3 different models, each available in 6 different colors. How many different combinations of model and color are available? There are a couple of different ways we could figure out this problem. First, I'm going to show you a visual representation. So if we say our models are A, B, and C. These are the 3 different models of cars you can get. And then for colors, we use the numbers 1 through 6, since there are 6 colors. Then you could get model A in color 1, color 2, color 3, color 4, color 5, or color 6. Same thing with model B. You could get model B in color 1, color 2, color 3, color 4, color 5, or color 6. And finally, the same with model C. Color 1, color 2, color 3, color 4, color 5, and color 6. And if we count up all of these different combinations, we have 6 for model A, 6 for model B, and 6 for model C, or 6 times 3, which is 18. So instead of writing this all out, we could have taken our 6 colors and multiplied it by our 3 models. 3 times 6 is 18, so there are 18 different model and color combinations. Find the length of the side labeled X. The triangle represented in the figure is a right triangle, as shown. To find the missing side of any right triangle, we can use the Pythagorean theorem, which is a squared plus b squared equals c squared, where the a and the b are the legs of the right triangle, or the 2 sides that form the right angle in the right triangle. And C is the hypotenuse of the right triangle, or the side that's across from the right angle. So now we need to substitute the values from our triangle to the Pythagorean theorem. Your A could either be 15 or x, because both of those are legs. So I'm going to use 15. 15 squared plus, and I can replace a b with x. X squared equals, c again is the hypotenuse, which is 25 squared. Now we need to simplify by squaring 15 and 25. 15 squared means 15 times 15, which is 225, plus x squared is equal to 25 squared, which is 25 times 25, or 625. Now we're trying to find what x is, which means we need to get x alone. To do that, the first thing we need to do is subtract 225 from both sides. 225 minus 225 is 0. Bring down the x squared term, bring down the equal sign, and 625 minus 225 is 400. And we're almost done. Again, we're trying to find x, not x squared. So in order to solve for x, we need to do the opposite of squaring x. The opposite of squaring x is square rooting x. So we must square root both sides to solve for x. The square root of x squared is simply x, equals the square root of 400 is 20, since 20 times 20 is 400. And when you square root a number, you're really asking a question. And the question is, what number times itself is 400? That answer is 20. So our answer is B. An airplane leaves Atlanta at 2 p.m. and flies north at 250 miles per hour. A second airplane leaves Atlanta 30 minutes later and flies north at 280 miles per hour. At what time will the second airplane overtake the first? Well, this is a DIRT problem, or distance equals rate times time. You see, we've got time, 30 minutes later. We've got rate, 280 miles per hour, 250 miles per hour. We've got distance here because both these planes are flying a distance, and that's how their rate and time are related. So we need to use this formula to help us organize our data. So first, let's find the distance for the first airplane. The rate of the first airplane is 250 miles per hour. So 250 times, and then all we know is what time the first airplane left. We don't know how long that airplane flew. So we've got to use T for time there. Now the distance for the second airplane, the rate is 280 miles per hour. And we do know a little bit about the time that the second airplane flew. If you'll notice, the second airplane is going faster than the first one. So if they left from the same place and they go in the same direction, they're both going north, then the second airplane is eventually going to catch up with the first and actually pass the first. And that's what we're trying to figure out, is at what time will the second airplane catch up to or overtake the first. So the second airplane won't have been flying as long as the first airplane when it catches up. It's going faster, and it left 30 minutes later. So however long this first airplane has been flying, the second one will have been flying that time minus 30 minutes since it left 30 minutes later. Now if you think about this, you've got two planes leaving from Atlanta. They're both flying north. And the question is, when will the second one overtake the first one? Well, this is what we're trying to find out, is what time that will happen. Well, at that time, both of these airplanes will have flown the exact same distance. We don't know what that distance is, but we know that it's the same. So we can take these two distances and we can set them equal. So the distance of plane 1, 250 t, is equal to the distance of plane 2, 280 times the quantity, t minus 30. And now we need to solve for t. So the first thing we want to do is distribute our 280. So I'm going to bring down this 250t equals 280 times t, 280t, minus 280 times 30. 280 times 30, 0 placeholder, 3 times 0 is 0, 3 times 8 is 24, 3 times 2 is 6, plus 2 is 8. That's 8,400. Now we need to get all of our variables on the same side of the equation. We don't want to have t on the left side and t on the right side. So I'm going to subtract 280t from both sides. 250t minus 280t, I'm taking away more than I have. So I'm going to end up with a negative. And the difference between 280t and 250t is 30t. So negative 30t equals, and by subtracting this 280t, I've actually canceled that term on the right side. And I'm left with negative 8,400. To solve for t, then, we need to divide both sides by negative 30. Negative 30 divided by negative 30 is 1, times t is simply t. Negative 8,400 divided by negative 30. First of all, a negative divided by a negative is a positive. Then we can cancel a 0. And really all we have to do is divide 840 by 3. Really, I'm running out of space here. I'm going to get rid of this so we can divide 840 by 3. 3 goes into 8 2 times. That's 6. Subtract and you get 2. Bring down the 4. 3 goes into 24. 8 times. 3 times 8 is 24. Subtract and you get 0. Bring down your 0. 3 goes into 0 0 times. So it's 280. But 280 what? Well, if you'll recall, we did t minus 30 minutes. So that would mean that these t's are in minutes. So we just found how many minutes the first plane, t, the first plane would have been flying when the second plane overtook it. So we need to first convert these minutes into hours and minutes so that we can then find the time, what time it was when that happened. So to convert these minutes into hours, there are 60 minutes in 1 hour, which means we need to divide 280 by 60. So we've got 60, 120, 180, 240. So 60 goes into 280 4 times and you get 240. You subtract and you get a remainder of 40 minutes. So that's 4 hours, 40 minutes. So 4 hours, 40 minutes after the first plane left at 2 p.m. is when the second plane overtook it or caught up with it or had traveled the same distance. So 2 plus 4 hours is 6 and 40 minutes. So at 6:40 is when p.m. is when that second plane overtook the first. Answer C.